Hello and welcome back. Are you ready to take the next step with your IoT mill? We're focusing on connecting it to your computer, configuring it, updating its firmware, and mastering the art of monitoring and debugging. If you followed the steps from our previous video, you're all set for this exciting journey. Let's dive in. All right, let's kick things off by firing up the command line shell. We're going into the directory where the Espressa framework lives. In there, you'll find shell scripts tailored for different operating systems, SH for Unix and PS1 for Windows. As I'm using Windows, I'll be demonstrating with export.ps1. Here's a pro tip. To save time, you can craft a script to automate this process. I've put the instructions for this handy trick in the video description. Now, let's head over to the IoT Mill directory. Here's where the magic happens. We run the command idf.py menuconfig, and voila, the configuration UI pops up. This is where you'll tailor the IoT mill to your needs. First stop, the MPU driver submenu. Make sure to select the correct chip model, ICM 20984. This is the one installed in IoT Mill. Next up, we're diving into IoT Mill specific settings. Ready to empower your IoT Mill with LTE network data transfer? Just make sure you've popped that SIM card in. Based on the mobile operator, you might need to add some APN configurations, but more often, it's not needed. What's next? Choosing the right transport to send out events to the cloud. You've got options like the MQTT protocol or ThingsBoard's HTTP. For now, let's go with ThingsBoard, since we already set up our ThingsBoard environment in previous videos. Then, we activate the Bluetooth gateway functionality in the demo project submenu. After that, we configure specific parameters for Bluetooth in its own menu. We're setting the operating mode to Mongoose OS Relay, targeting devices with specific names, in our case, those starting with PortaOne. It's like telling your IoT mill exactly what to look out for, since there may be many other Bluetooth devices in the range. Let's talk about the extraction of specific attributes from the device. You can specify the name of a parameter for extracting all sensor data at once in JSON format, if device supports it. Alternatively, what is the name of the parameter to extract the list of available sensors, such as temperature or GPS coordinates, from the device? IoT Mill will then extract the meter readings provided in that list one by one. This way, if different devices have a different set of sensors, for each device all available measurements will be extracted. Finally, as a last resort, we can state which specific metrics we want to extract from the device and send them to the cloud. In our example, we're focusing on temperature and humidity. Done configuring? Great! Hit Escape to exit and then press Y to save your settings. Now, it's time to build the updated firmware with the idf.py build command. While that's cooking, let's connect the IoT mill to the computer via USB cable. There is a separate video on how to prepare that cable. After a quick refresh in the device manager, you'll spot a new entry under Ports, COM, and LPT. That's your IoT mill, now linked as USB serial port COM5. Once the build is complete, it's time to bring your IoT mill to life with the new firmware. Use the idf.py flash command and set COM5 as the port number. In just a few moments, the firmware is all set up on your device. To see the magic in action, let's do idf.py monitor. And there it is. You can watch as your IoT mill connects to the LTE network, ready to transmit data. Let's review what we just did. We initialized the shell command line environment using the export script. We used idf.py menuconfig to configure IoT mill settings. idf.py build command is used to compile an updated firmware. We connected the device via USB and found out which serial port was assigned to it. We wrote the new firmware to the device using idf.py flash command. Finally, we were able to see the debugging info from the device using idf.py monitor command. In our next video, we'll show how to activate the sensor device so your IoT mill can read its data via Bluetooth. Stay tuned, and thanks for joining me on this tech adventure. Until next time, keep exploring the wonderful world of IoT.